Okay, basic differentiation. So before you got into calculus, you always talked about average rates of change. So, for example, the average velocity was the total distance you traveled divided by the total time. And in general, the average rate of change of something is the total change in the dependent variable divided by the total change in the independent variable, which is we can write as change in y over change in x, delta y over delta x. Well, the cool thing about calculus is that now we can find an instantaneous rate of change. We don't have to have any change in the independent variable. So what we say is that the limit as delta x approaches 0 of delta y over delta x becomes a derivative, and that Greek delta becomes a d. And so we get dy dx. And that is our notation for a derivative, dy dx. That means the instantaneous rate of change of y with respect to x. So let's look at some rules for taking derivatives. First of all, the derivative of a constant is always 0. And the reason why is when you think of a derivative as a rate of change, which is a slope. So let's say, for example, we have a constant function y equals 2. Well, that's a horizontal line, right? And what's the slope of any horizontal line? 0. There is no change. So the derivative of any constant is 0. Okay, so what if you have something besides a constant? Well, we have this beautiful little rule called the power rule. And what it says is the derivative of x raised to the nth power is that power comes down, becomes a coefficient, times x raised to the n minus 1 power. So, for example, the derivative of x squared with respect to x, I'm going to take this little exponent there. It's going to come around front. It's going to become the coefficient. And then I'm going to subtract 1 from the exponent. And so I get 2x. The derivative, well, let's say we want to do the derivative of x to the 5th with respect to x. Okay, the exponent comes around front, becomes a coefficient, and then the exponent subtracts 1, and I get 5x to the 4th. That's the rule. That gives you the derivative. Okay, now some notation. If I told you that f of x was x cubed, and I said find f prime of x, f prime of x is just another way of asking for dy dx. And so you would say f prime of x is 3x squared. Or I could say y is equal to x to the 8th. Or let's do something different. Let's do something interesting. Let's say that y is the square root of x. Well, we can rewrite that as x to the 1/2. And guess what? The power rule works for fraction exponents just as much as integer ones. So we can say y prime is 1/2 x to the negative 1/2. Remember that we subtract 1 from the exponent, and 1/2 minus 1 is negative 1/2. And you can write that as 1 over 2 root x. So y prime, f prime of x, and dy dx all mean the same thing, the derivative of y with respect to x. Okay, couple more rules. The derivatives of sine and cosine. It turns out that the derivative of sine is positive cosine, and I don't have time to really go into the proof of that, but it is in any calculus textbook. The derivative of cosine is negative sine. So guys, you just need to memorize these, okay? These are really important. The derivative of sine is positive cosine, and the derivative of cosine is negative sine. Let's do some examples. Because we have the power rule, we can put it together and take the derivative of any polynomial now. So for example, the derivative of y equals x to the 16th. dy dx is 16x to the 15th. How about 1 over x to the 8th? I can rewrite that as x to the negative 8. And so y prime is negative 8 x to the negative 9. How about the 4th root of x? G prime of x is 1/4 x to the negative 3/4. What if f of t equals negative 2t plus 3t minus 6? Okay, f prime of t. Now this exponent is going to come around front, and there's already a negative 2 there, so when they multiply, we get negative 4 t to the first plus, now t to the first, that 1 comes around, multiplies by the 3, and I get t to the 0, and the derivative of any constant is 0. Well, t to the 0 is just 1, so our derivative is actually negative 4t plus 3. Okay, what if y equals pi over 2 sine theta minus cosine theta? dy d theta, you notice I'm using the d theta because my independent variable is theta now. dy d theta is pi over 2 times the derivative of sine, which is cosine, minus the derivative of cosine, which is negative sine. And we get pi over 2 cosine theta plus sine theta. Okay, well how about this rational function? What we want to do is divide that x squared into each term. So it's really x to the first minus 3 plus 4x to the negative 2. And now we're ready to figure out what f prime of x is. And I'm going to get 1. The derivative of negative 3 is 0. And the derivative of 4x to the negative 2 is negative 8x to the negative 3. And you can write that as 1 minus 8 over x cubed if you wish. We've already talked about rational exponents. So h prime of s is 4/5 s to the negative 1/5 minus 2/3 s to the negative 1/3. So since the derivative is a rate of change, then when we take the derivative, we can also use it to find the slope of a function, because slope equals rate of change. So y prime is 9x squared, and the derivative of negative 10 is 0, and I want to find the slope at that point. So y prime of 2 is 9 times 2 squared, which is 36. So that is the slope of this cubic function at that point. And if I want to get the graph of the tangent line to a function at a given point, I just need a point and a slope. So dy dx is 4x cubed minus 6x. We plug in 1. So dy dx of 1 is 4 times 1 cubed minus 6 times 1, which is negative 2. So there's my slope. There's my point. And my line is going to be y minus 0 equals negative 2 times x minus 1, or y equals negative 2x plus 2. So the derivative is very powerful because it gives us the slope of any polynomial at any given point.